Okay, section 6.2 on page 282 talks about vector addition, and vector addition is really very straightforward. There's a couple of rules or little helpful tricks and hints to teach you how to add vectors, but really think of vector addition as just two vector quantities happening together. So if I was riding a bike, let's say, represented by a vector quantity, and I was pushed by the wind just a little bit off course, or a canoe and a wave, let's say, or an airplane and the wind. So the combination of those two vectors would be my resultant vector. So let's say if I'm in a canoe and I'm paddling across at a certain speed, and the current or the waves push me off course a little bit. So the first vector is my paddling speed. The second vector is the current, and my resultant vector is where I end up. And that's really the way to address it. With vector addition, you simply, and the easiest way to do it is to create a triangle. And there's a good example here. Sometimes we have to move the second vector. In this case, it'd be vector B to the end of vector A, and see that the two vectors A and B, just as I said, act together and give us a resulting vector AB. We can talk about tails and tips and tails and heads of vectors, and that's really what we do is we just translate one of the vectors, slide it over so that it ends up on the head of the first vector, and we connect sort of head of the vector to the tail of the second vector. We'll do just a real quick example here. I'm going to do my best here with this drawing. I'm not sure that okay, my diagrams are going to be very good, but okay, so here are my four vectors, A, B, C, and D. So I'm going to represent vector A plus B plus C. So let's do it this way. Let's go A. I'm going to go A. Okay, then I'm going to add B to it. So B would be like this. And I'm going to add C to it, and C is down here. Okay, so my resultant vector, okay, is the combination of these three vectors added together, or I could say it, okay, since I started here and I ended here, my resultant vector is in red here. Okay, let's do the second one, A plus B plus C plus D. Okay, so I think I can probably do it here. Might have some space. So let's go back to my black screen. Okay, my black pen. So A, I've got A, then B, then C, and then D, and it looks like the vector D goes 2 over and 1 down. So 2 over and 1 down. And then there's vector D. So it's A, B, C, D, and those are added tail to tip. And my resulting vector, just for a change of place, I'll do it in purple. My resulting vector is here. And that would be the vector A plus B plus B plus C plus D. Okay. You can also use the parallelogram rule, and parallelogram rule really is just two triangles. Okay, so that look at parallelogram rule is not anything different or new, but if you've got two vectors, you can just make them into a parallelogram and close off a parallelogram, and then talk about, okay, sort of the triangle. Now, whatever way we cut it, okay, it could either be going from A to B or going from B to A, and we're adding anyway, and the resultant vector is here. So think of it this way: if I've got well, let's talk about a physics application. So if I've got okay, an object here, and one person is pulling on the object represented by vector A second person is pulling on the object represented by vector B, the resulting object is going to fly off this way, right? And you're going to have a combination of A and B together. So A and B together. Again, that would be B. I know my diagram's not perfect, but that's a kind of a nice way to look at it and consider it that way. Okay, so let's use the parallelogram rule to compute some of these ones here. Okay, now, so A and B, so here's A. So A plus B, so A, okay, plus B, so I have A, okay, plus B, Okay, and I do a sort of a combination. And there's my parallelogram rule. Okay, so yeah, I just close off a parallelogram. Now you guys can decide however you want to add these together. That would be A, and the diagram's not very good. Let's take a look at B and C. So B, so this is vector B, okay, and then vector C. Okay, and I like B. Okay, personally I like the triangle rule, but again, a parallelogram rule is just a combination of two triangles in a lot of ways. Let me try and draw C again a little bit nicer. Okay, so the parallelogram rule, it just sort of closes this off. Okay, so I'd draw C this way. Okay, and then I'd draw A here. Okay, and my resultant vector. Okay, there's my resulting vector. Okay, and I can find it by using the triangle to the left or the triangle to the right. I basically just take my two vectors and close them off. A and C, I won't go on my grid, but A and C, A plus C, and it's just A plus C, and we've got that same sort of situation. Okay, exactly. Okay, play around with those. I think a couple of homework questions have you do that thing. And as I said, I don't care one way or the other. Okay, if you use the triangle rule or the parallelogram rule. Can make vector applications outside of the math class, so real world applications, physics applications, require a review and the use of the sine law and the cosine law. And the sine law, again, this makes some sense. The sine law and the cosine law are used to find sides and angles of triangles. And if we've got two vectors or a combination of a vector system working together, we can draw the system and then incorporate the sine law, the cosine law to find those interior angles, which we need for direction, right? And magnitudes, which we need for, sides of triangles, which we need for magnitudes. So I'll leave these here. You have these, we talked about these in the last section, and that's kind of the work we've got to do here with this, okay? Okay, so magnitude and direction, just again a review of how it looks on vectors and all these other situations. Real quick, there are a couple homework questions that it's going to require us to do this type of thing. All right, so what have we got here? We've got, okay, this particular, I don't know if I've got a previous one here. Oh, we got to do this one. Okay, this is the one I missed. Okay, so given the magnitude of two vectors 4 and 7 and the angle, it says the angle between them when placed tail to tail is 60 degrees. So I think that's theta is 60 degrees here. I'm going to go A is 4 and B is 7. I want to find the resulting vector A plus B, and not only that, I think just the magnitude. Yeah, we'll find the magnitude and the direction. So magnitude and the direction of the sum of the vectors here. Okay, so I need to find the magnitude first. Okay, and I'm going to use the sine law, or sorry, the cosine law. Okay, that's this vector here. So I've got it's equal to, and I've got then 2 vector A times the magnitude of vector B times the cos of theta, with values in here. I've got 4, 7, and then the cos of, now this is a little different. Okay, so it's this angle 60, okay, but in my triangle it's this angle that I'm interested in, because this is my triangle I'm using the cosine law on, right? This one right here, so it's a cos of 120. All right, so I've got 16 plus 49, and I have this as plus. The cos of 120 gives me a negative, but there's a negative 2, so plus 28. Okay, and I get a result of 93, and that was squared. Okay, sorry, that was squared, so I have to take the square root of 93. approximately 9.6. And I like that. That seems like the practical or sensible answer here. If this was 7 and this was 4, okay, and I have it at this angle, it's clearly my resultant, okay, vector sum is going to be bigger than 7, okay? It certainly wouldn't be 7 plus 4, it won't be 11, but it would be somewhere between 7 and 11, right? Okay, magnitude. I think I've got to do, okay, magnitude, or sorry, direction. Okay, well, do I have direction? I want direction. I want B here. Okay, so I need sine law for B. Okay, let me just pause this and work this out. Okay, so I did the calculation here, but I'm just going to focus on that. So I'm going to find B. Okay, I'm going to use this as my direction of my vector sum, and I'm going to say it's in relation to, so my vector sum is off at an angle in relation to the vector B. I just found my a plus b side, 9.6. I'm going to relate the sine law with 9.6 over the sine of 120 is equal to 4 over sine of b, or I'm going to do the reciprocal of that. So I'm going to say sine b over 4, that's the corresponding side with angle b, so sine b over 4 is equal to sine of 120 over 9.6. Cross multiply, get the ratio, and then take the inverse sine on my calculator, I get 21.1. So that's my direction. Okay, so my resultant, I could say, okay, my resultant vector sum is 9.6, okay, at, okay, 21.1 degree from vector B. Okay, as long as I have an angle and an orientation, I'm good with that. I need for vectors, I need a magnitude, okay, and I have that magnitude, and I need a direction, and I have that direction, very specific direction. Okay, let's continue with one more here. Okay, so here's the situation. We've got the vector sum given, and we need to find the angle between A and B. Okay, so let's see if we can draw this. Okay, so we've got, okay, I'm going to draw, okay, best I can, just get an idea. So I've got, I'm going to go vector A is here, 4, okay, and I'm going to draw vector B is 6, okay, and I've got this AB vector of 8 was, okay, and this one was, all right, I want to find the angle between, okay, so I want to find the angle between A and B, and that's probably, okay, this one right here. Well, what do I have here? Okay, well, I can certainly use, okay, I can certainly use 3 sides, and if I have 3 sides, I can use the cosine law, and the cosine law, okay, is back to 2 slides here. I'd have okay, this one, and then I'd have also B in this case. Okay, so I've got 8 squared equals, okay, 4 squared plus 6 squared minus 2 times 4 times 6 equals the cos of B. Okay, now this time I've got to do a little bit of rearranging, okay, and solve for B. So I'm going to, okay, write the cosine law. I'm going to rearrange as this. 8 squared minus 4 squared. I'm going to bring the negative, I'm going to bring the 4 squared over. I'm going to bring the 6 squared over. Okay, that equals, now some of you have maybe seen the cosine law written like this before. Okay, when I have to solve, when I have 3 sides and I have to solve for one of the angles, okay, I take, okay, the biggest side and take away the other 2 sides and then divide it by, okay, this coefficient right here. Okay, either way, I work this all out. Okay, I get this to be negative 0.25. That's the negative, or sorry, cos of B. Then I do inverse, okay, cos on my calculator, right? And I get B to be 104. this angle right here, okay, as an acute angle I'm interested in. Okay. The corresponding angle here, 76 degrees, and that was sort of this reference back here, okay, to this little situation right in here, okay, where we have to consider, okay, the angles as they're oriented. Okay, it doesn't make sort of any practical sense that you would do it in that way and accept that answer. Okay, last slide. Okay. Okay, vector subtraction. Okay, vector subtraction you'll see in some of these examples, homework examples, where if I have to subtract vectors, I'm just going to add the negative of the vector. Okay, so add the reverse. So if I have the situation A and B that I have to subtract from one another, I take the negative of B, and then I add those together and set them up in a triangle or a parallelogram law. Okay, again, that was talked about in the last one when I had this, okay, this angle. And that is it for, right, oh no, zero vector. Okay, zero vector turns up in the homework question as well too. So if I have two vectors, okay, that I'm adding together, or a series of vectors that I'm adding together, and I end up back at the result, I represent that as zero magnitude, but I also represent that as the concept of a zero vector here, where I can write, okay, the vector 0 as that. Okay, there's no magnitude, zero magnitude, and we're back to sort of where we started from. But again, that turns up in the homework, so we need to be aware of that concept. Okay, that's it for the homework questions. There is a wide variety of these. I think we're going to rule out 13 and just do 12 and 14. Okay, thanks and good luck.